This is an atom. It might not look like much, but it is an atom. In fact, this is an atom of phosphorus. So, first of all, what is an atom? Well, an important part of an atom is the nucleus. That is this inside area you see right here. Now, there are two types of particles that you see inside of the nucleus. These are protons and neutrons. Now, protons have a positive charge and neutrons have no charge at all. So, for example, in phosphorus, the basic version of phosphorus, which I will call phosphorus 31, you will understand why in a second. There are 15 protons and 16 neutrons. You can count them yourself. So, 15. Actually, I'm sorry, this is the wrong nucleus here. That would have ended up being a completely different atom. Here, 15 protons, 16 neutrons. Now, the interesting thing is you might be able to tell 15 plus 16 equals 31. And that is true. That is why this is considered phosphorus 31. 31 is the relative atomic mass of phosphorus. Well, this specific phosphorus with 15 protons and 16 neutrons. And the 15 proton part is actually what makes phosphorus, well, phosphorus, because if it had a different number of protons, it would not be phosphorus. It would be some other element. Now, besides the nucleus, there is also another important part, which is the outside of the atom, which is where the electrons go. Electrons. They are tiny, negatively charged particles. And in phosphorus, there are 15 of them because as a neutral atom, the number of protons has to be the same as the number of electrons. So this is where you'll see your 15 electrons. So there are 2 in the innermost shell. There are 8 in the second shell. So you can see how they'll fill up. All right, now we can start to fill the third shell. So let's start doing that. 1, 2, 3, 4, 5, and look, we've run out of electrons. So unfortunately, we cannot completely fill this outer shell because it requires 8 electrons and we only have 5 at the moment. So that's kind of annoying. All right, before we get back to this, let me introduce the concept of an isotope. So basically what an isotope is an isotope is an atom with a different number, and I want you to write this down, of neutrons. So the number of protons is still the same in an isotope, it just has a different number of neutrons. So let's look at an isotope of phosphorus for a second. Phosphorus 33. Phosphorus 33 is very similar to phosphorus 31 in that it has 15 protons and 15 electrons, except, here's the interesting part, it has 18 neutrons. So let me just put an extra 2 neutrons to turn this phosphorus 31 into phosphorus 33. Here we've got phosphorus 33 now. And I think that's pretty cool. All right, let's turn this back into phosphorus 31 for a second. And think about what an ion is. Ion. So again, it's basically just a regular atom, but with a non-zero charge. So how would you change the charge without changing the number of protons? Because remember, that would change the type of atom or element it is. Well, you can change the number of electrons. So remember how there is an incomplete shell of this phosphorus? Well, we can fix that by making an ion of phosphorus. So this one is going to be phosphorus 31, except it has an ion of -3. So what this charge means, because remember, electrons have negative charge. So if you add 3 electrons, as so, 1, 2, 3, you have actually subtracted 3 from the net charge of this atom, which is now an ion. So as you can see here, it has 15 protons. It has 16 neutrons, but this time it actually has 18 electrons. All right, now, what is a compound? A compound is when you have 2 atoms and they're attracted to each other because one of them is positive and one of them is negative. Let me... There. So we already have the negative part, this phosphorus right here, but the positive part is this, aluminum. So let's inspect the stats of aluminum right here. This is specifically an aluminum ion. So it has an atomic mass of 27, and it has a charge of positive 3. And that's nice. So as you can see, 13 protons. 14 neutrons. And 10 electrons. And since there's more protons than electrons, it is positively charged, which means it's the opposite charge of the phosphorus ion, which is known as phosphide. So these two ions will start to attract to each other. Let's see this. And what we've got now is a compound. Notice they're not sharing any electrons. That would be a covalent bond. This is what is known as an ionic bond, which is two ions attracting each other. And this is what is known as aluminum phosphide. Thank you for watching. Bye.